Here's my Lab 5 first order sensor video for ENME 351. Here is my circuit. As you can see, this orange wire right here is the comes from the digital output pin 2, and that's my voltage supply that I can set to high or low. The green runs from that to the A1, so I can monitor whether that voltage value is high or low. It would display as 1023 or 0 since it's a analog input. And then I have my resistor here, which in this case I'm using a 10K. Here's the 100K. And those could be interchanged and this whole lab repeated with the different resistance value. Then I have the yellow wire here, which runs to A0, and that is for the V sub C value, the voltage across the capacitor. And that is read, like I said, through A0. And then here's the capacitor, and which it's grounded here, and then my ground wire runs there. So moving on to the first part of the lab where we had to run this MATLAB code. You can see here it plots both the 100K, which is the red line, and the 10K, which is the blue line, response, and the tau value, which is R times C for the 100K, would be a larger tau value, so you can see that the time it takes to reach that 5-volt steady state of the capacitor charging, it takes longer than it does here for the blue line, which is the 10K. Moving on from that, go to the Arduino code. Pull that up. Here's my Arduino code. I'll scroll through it so you could pause the video and see it if you'd like. But when I run the code here, change this to 10,000 real quick, upload and run the code. And I'll pull up this serial monitor here, and after 5 seconds of a delay, it sets to low. So after that 5-second delay, then it should start running, and here you can see it running. I will stop the auto scroll real quick. You can see the left is VN, which is either gonna be set to 0 or 1023 for 0 or 5 volts. And then on the right side, if it is 0, it'll show the capacitor discharging, so you can see the value is getting closer to 0. And if I kind of scroll forward here a little bit, you can see once it hits 1023, as I come down here, I'm going down now, you can see that the V sub C value is increasing, getting close to 1023, until that eventually then we go low again, and then it starts to discharge. And it would just keep repeating that cycle on that tau based off of the resistance. And then moving on from that, we go to the processing, which is right here. The only things I needed to edit on processing here was the fills and the text and lines to show the different lines for the different voltage values, and then also for the legend, which is right here. You can see all of that stuff here. So if I run the processing code, you can see this here. It takes a little bit to load. There it loads. You can see the legend up here. VN is the red dots, VC is the green. You can see the red goes high, low, high, low. The green charges when it's high and then discharges when it's low, and you can see that between the 0 and 5 volts. Moving on to the last part would be the last MATLAB code, which I have my resistance value here of 10 times 10e to the 3, which would be the 10K resistor, which is what I have in my circuit. I bring in my data file that I got from processing, and then I edited this to be for volts, and I edited the plot to reflect the volts also. So when I run this now, you can see that here's a plot. You can see it's 0 to 5 volts, and this is kind of representative of what we've already seen on the other plots. If I'll try to zoom in real quick here, and you can see that it charges, and then it goes to low, the VN goes low, and it discharges, and it repeats that. And the only difference if I were to use the 100K resistor is it would charge and discharge at a slower rate, and I would change that here in my circuit.